about what can you do to make it worse or better, depending on implementation. So I guess on the one hand, you might say our thinking has been very simple on this point, although whenever I get into policy questions and people try to complicate things, I get even more worried. So our simple thinking on this, Gene, is that what we've tried to build is a system which is in-user controlled and is totally, the policy is totally up to the user and people who agreed to policy. Now, that can still be misused for the reasons you said. The Chinese government can, although it, again, just simple-mindedly, it does, it's hard to imagine how it can be really effectively misled because the hardware is comparatively easy to break. You don't have to turn it on. There's a bunch of stuff that sort of puts a barrier between it making it like a really reliable, ironclad, oppressive tool and just because it's kind of in user control. So it's hard to know. But if you were to say to us, we found something that made it, we found some change, we found a flaw in your system so that it's not really in user control or that it's not really policy independent. We kind of freak about that and try to fix that right away. If you said to us, you know what, we found some way to make it so that the Chinese government can't really authenticate their citizens because, I can give you a list of bad things that are going to happen when they do that. We'd be stuck in this position where we're thinking, yeah, the Chinese government can do that bad thing with it, and the U.S., not a bad analogy, and Gene could do something good with that. What do we do? How do we,
Unlikely.
Well, okay, but all right, never mind. So somebody else can do something good. How do we balance those two? If we're in the position of setting policy by technology, we're kind of in and we're Microsoft. Let's not forget, we're kind of in a pretty awkward position.
I think the suggestion before the break, which apparently was also made at a prior meeting, was using creating having a group of people write a report that was a sociological threat analysis.
I think that's a good idea.
Which would kind of drill a few levels down to see, well, they could already do that, or why can't they already do that?
Right. I think that's a good idea.
And who knows? In that kind of conversation, they might find, depending what the mix of people were and how long they were they might find something like that, a nit that you guys could, to your surprise, could change that could actually have this big difference.
Yeah.
And until that work gets done, right now it seems like it's this thing you guys talk in the halls or maybe longer. And until that gets done, it's kind of theoretical, right? And then such a report would seem to have potential benefit. It's a few hundred pages, and seems like something.
One thing that might lead to is building or suggesting some compensation mechanisms. So, for example, this technology enables pinpointing location and possibly even keystrokes by a particular authorized person. You might suggest if you are using this and you are concerned about such a threat, you might use anonymizers.
Right.
And if you do that systematically, at least you have some idea of how to mitigate these things.
Right.
That might come up. So if you just go on the do side but not on the undo side, you open yourself to all sorts of potential.
And it's hard to argue against doing the analysis. I guess the one thing which I'm in the back of my mind I'm suffering over is, again, we built it so exactly what you said could happen. If we found a flaw like that, somebody can insert an anonymizer. Everything works fine. They can rely on it because we've done sort of the simple thing of just making it policy independent. I guess that's the thing that sticks in my mind. And you know what? It's just not really resolvable. I keep on saying, suppose I was the poor schmuck who's trying to introduce cars right now. Just cars, which not everybody thinks is a fine idea. I'm just sitting there going, it can be used for bank robberies. And it's hard for me, probably from where I am, to imagine that somebody's going to come to a conclusive way. Build a car so people can do what they want, which is, I think, ultimately the goal, and not have any of the bad things happen technologically.
But you don't have to do that.
Yeah.
It would be more like saying, if we know what we know about cars, and if you go back and you look at the horrible traffic fatalities, you say, well, safety belts, which were not there.
Right.
You know, airbags.
Right.
And so on and so forth. And so I don't think we're saying, you know, you have to, in some Back to the Future way, figure out all the kind of things that you can't know, but I think it's more on the level of what are the seatbelts, what are the airbags.
I believe John was talking about safety. You were talking about misuse.
Yes.
Right.
Yeah, sure. Which I don't think you
Yeah,
I don't think
I
it's your
think, but I
responsibility.
think it's, you know, this is a question as technologists,
What's our responsibility here? And I think it was the nano guys. I think they actually had that kind of
Mentality?
they actually, I think that community went through a pause for a few years while they tried to figure out the ethics of it, and then they went going. So I think that, like you say, it could be when the report's all done, you just keep doing what you're going to do anyways. But I think until the report gets done, you know, who knows what you're going to do.
And then I think a report would be useful, but I think that the hope would be that out of a report, out of the process of going through the report, you would be able to develop some questions, right? Like I'll give you an example. When I was in CBP, I helped develop some stuff looking at which, you know, standards that were going through IETF raised social concerns. So, you know, did this create a new way for people to manipulate messages or content in between the endpoints? Did this create a new way for people to, you know, engage in different kinds of traffic analysis? You know, trying to create a list of questions, you know, that get at some of the broad issues that you want to get. You know, it was a start, you know, for me, but I think that's the kind of corporate report would help you think about what are the kinds of questions you need to ask so you could refine some kind of metrics. It could be useful, not just here, but in general.
So, Gene, let me actually turn the question around you for a minute. So one way I might pose the question, in some ways, I'd like to think some of that thinking has been done. Because if I walked up to you and said, suppose I had a technologically perfect way, which was policy neutral, to authenticate, authorize, and you know, to do what computer security has been trying to do for a long time. In some way, in some very abstract way, at some level, what Palladium is not very different from that, right? We've all been trying to isolate and be safe and authenticate the things we're relying on, and then authorize based on some policy. Has anybody done a good job of analyzing that, even in a technologically less perfect, less good? I shouldn't say perfect. God, Christ knows we have problems, but you know, in a less formal environment?
So maybe
because it's a generic security problem. Whatever you do security, you're making something safer. But
well, there are if you want to go into this as an example, identification, authentication, and authorization are different. For instance, being able to have anonymous cache has turned out to be something that people still want, despite the convenience of electronic cash, credit cards, and other kinds of things, for perfectly legal reasons having to do with privacy. So having perfect authentication is fine.
right.
But if it is used in such a way that I feel compelled to have to be authenticated, that leads to invasions of privacy.
Right. And that actually is an area we try hard to do.
And so that's kind of what I'm trying to get at this.
So there was a National Academy of Sciences study, right? You were part of it on the tension between authenticity and privacy. So, and perhaps some input from there would be useful, just to sensitize some of the designers as to what.
Okay.
I think Virgil's point about seeing if there are electronic countermeasures that could be available to deal with some of these problems is a pretty powerful one. But I think if the question is, for example, should, let's say, Palladium omit a certain feature or design it in a different way in order to prevent the Chinas of the world from misusing it, Microsoft is an unusually knowledgeable and influential computer company.
Although also an unusually suspected one.
Exactly.
Yes.
But the Chinese government has considerable resources of its own. It's not like if, let's say, Microsoft decided, oh, this is such a horrible technological thing. Let's burn all documents having to do with Palladium.
Uh-huh.
It's not like it would be impossible for the Chinese government to build the very system
that's right.
you're complaining about. Now, it would be harder, and Chinese government
Costs more money.
Pardon?
Costs more money.
It could cost more money, more risk, and various other things. But I think it's important to have to be modest about the degree to which our ability to guide Microsoft can prevent the Chinese government.
No, that's right. Somebody, I think Dick Brass did this said this about DRM and the Chinese government roughly, and I don't want to rat on the Chinese government, but he said, it's hard to say you're the guy who should make policy against an entity that has nuclear weapons when you're a software company. But roughly, what you're saying is true. Public policy is public policy, and ultimately, we're not the guy setting it.
I respectfully disagree. I don't think the Chinese government has the same influence over Intel as Microsoft does. I think you guys are making this happen because who you are. And I don't think any single sovereign nation, including the United States, could make it happen.
Well, I'm not quite sure about that.
I respectfully tell you this.
Okay, give me an example.
Do you think that Microsoft has more influence over Motorola than the Chinese government when Motorola spent several $billions establishing factories
I said Intel.
in China on the terms that the Chinese established?
Well, but it could influence Motorola to make the chips that will do the Palladium stuff. I mean, once you can't. It's not like we can bury the technology. Even if
I could pretty much guarantee it's around.
It's going to happen. I think it's going to happen anyways. I'm not sure that's obvious to me.
It's not your job to make sure that the Chinese government does no harm.
Right.
It sounds to me like you'd like to make sure that your products don't do any harm. To the extent that
That's possible.
it's harm that's foreseeable,
Yeah.
make it avoid.
Right.
And that's a good goal. Nobody's
Right.
asking you to stop the Chinese government. Yeah.
So,
Thank you.
does anybody see any change to the architecture that would enable a better? I mean,
Yeah, actually, that's a great question. So let me ask it that way. So you've seen, at the top level, you understand it the way. Or Gene, actually, you probably understand it nearly perfectly from the point of view of policy. Would you change something? Say, okay, I know a way to make sure that some class of bad things won't happen.
So I can give you a concrete example of that. So our crypto chip is designed by this committee called the TCAAB, which I'm involved. And
I can't hear you.
Go by the front.
Actually, that's on. So
I was trying to give a concrete example of a platform change that would have consequences for the usefulness and backfill applicability. The TCAAB is defined there's an active thread on the TCAAB design include email threads regarding should the root key in the TPM, the root keys in the TPM. One of them is effectively used for storage of local secrets, and the other one is for attestation. The local secret storage chip secret, there has been, right now it can be used by anyone using the mechanisms that John has described, but cannot be extracted by anyone. There has been talk about putting in essentially an escrow facility for this root key.
A what?
Escrow
facility. So what would that do for you? I mean, in one sense, if you let the escrow facility be under the control of the local user, then this makes it means you can't do DRM any longer.
we can't do any trusted operation.
You can't do ad hoc trust operations with someone you don't know before. If a corporation choose to use their own escrow key in all the machines that they own, then they can set up these local trust networks, but you can't have cross-trust so easily. So that's one thing.
So cross-trust independently based on that.
Right. You could have a third party.
That's a broader statement.
Yeah. I didn't get your clarification. Consider cross-trust based on that. Yeah. I mean, yes, fair enough. So the other thing that's going on is right now the authentication key, the attestation key, is fixed at manufacturing time and can never be changed. There's another threat going on, and this has got to do with FIPS requirements as to whether you should be able to change that. If you were to change it, for the average consumer, this key has value because it is accompanied or can be accompanied by a certificate saying you have a platform of a particular class. If you were to roll that key, replace that key, change that key, then your PC would no longer be as valuable because you could no longer engage in these ad hoc trust relationships. So there are things going on right now regarding the sort of fundamental hardware underlying our platform. It has been my position up until now that in the two examples I give you, that the storage root key, this root symmetric key, should not be escrowable nor migratable, and the endorsement key, this attestation key, should not be changeable or deletable, because we can build software underneath that does everything we want to do. We can, given a non-migratable key, we can do secrets that are under the control of the user, secrets that are under the control of the corporation, secrets that are under the control of Disney. So it's a more useful platform. So that's been my position up until now. Same thing with the endorsement key. I don't want my mum to accidentally delete her endorsement key because what the hell do I do? It may be that we can think a little bit more about this.
Well, so essentially you have a unique identification system in disguise with all that debate that comes along with it.
That's not the point I'm trying to make.
I know.
The point I'm trying to make is we are policy neutral at the bottom level. We could allow policy to be injected at the bottom level. Is this good or bad?
Well, no, by not choosing doesn't mean to be policy neutral.
Yeah.
I mean, I don't know.
I guess what I'd say is we're choosing to be policy neutral. The mechanisms we all insist or try to insist that they are policy neutral.
But he was just giving a whole bunch of policy justifications for the choice that he's been making. I mean, they might not have been privacy, but they were surely policy justifications.
So I'm saying that given the design it is right now, we have a broader choice of policy types that can be expressed and that we can enforce. If I were to make the two changes that I suggested, we would have fewer policy types that we can enforce. Is this good or bad?
Right. It's not neutral in all senses.
Well,
Yeah, but disabling a policy, deciding to allow a policy to happen or not, has impact on future policies, right?
So yeah, again, at the software level, we're going to be a much richer set of policies can be expressed to the system and we can enforce. So, we're going to have a dial which says, I don't want to use any of this stuff. I want to use this stuff, just the random number generator. I want to use the stuff for local secret storage, but never use any of this authentication stuff. Or I want the whole, shebang. And we'll have a little slider is what it's going to look like, and you'll be able to opt in to the extent that you want. So we can do expressive policy in software, given the hardware as it's designed now. If we were to make these changes that I'm talking about, there are some things we just simply couldn't do. Or at least we couldn't do if the user chose to set their platform up in using this.
Your model is like for that user, there's a slider or something that set. Is there something about what you've done, which I don't understand this stuff, is that a third party could, presumably a third party could remove that slider and wouldn't give the individual user that.
The third party being another software company?
Somebody else who would make it.
Sure. And the sort of change that we could make to the hardware is that the Chinese demand that they put their escrow key in the TPM hardware platforms. If we were to make this change to the hardware that we're talking about actively right now, is this a good thing or a bad thing?
So suppose that you have this dial which would enable people to choose certain policies. In the abstract, that sounds wonderful, but what you also have to do, and I think this was Eugene's point yesterday, you have to think in terms of the implications of those policies. In other words, before I turn the dial...
I'm going to stand up here purely as a technologist. I mean, I heard what you said in the previous conversation, and I buy it. I've heard the conversation before, but you can ask these questions to him.
No. I mean, I'm addressing it to all, not just to you. I mean, you are standing there, so I'm directing it to you.
I'll stand, so you can.
I'll direct them to you.
You can get cross-eyed.
I think that the big point which was mentioned yesterday, you have these optics, you have these dials, you can tweak and so on, and we can choose. but we have to be informed. We have to make an informed decision.
Right.
So essentially, building those dials without telling people what the implications of those policies are is not part.
So I think the concomitant thing that he probably meant is, if it was our job, we'd make sure you were informed about the. But on the other hand, if it's not hardware enforced, somebody can put another nexus, and they don't have to inform anybody of anything, as the right. So yeah. So any.
But we are talking about hardware. Placing policies in hardware in some sense. That's what we are talking about. And by the way, one thing that comes with it, and it's in a totally different direction. The user manual, whether or not online or offline that you write, better be short and very, very clear. Otherwise, it will not be read.
Well, that's the other benefit of keeping it like really simple and saying, look, this does this.
Yeah.
You know, if you allow somebody to run their nexus, here's what happens, here are the dangers, and it's very simple. Now, you got to be careful, you got to go to them, but it's clear that if you don't turn that on, they can't do that.
And if you do that, by the way, people will not be as suspicious of Microsoft as they are now, because Microsoft in the past took these technical decisions without really exploring the implications. For example, there was a key which was placed in DOS called the NSA key.
Oh, yeah.
Right? Remember?
Oh, yeah. Do you remember that, Art?
Named it.
I think I remember that.
You named it that way, and you know what the implications.
Yeah. So it's sort of interesting, because I think the thing that's a little bit jarring is, in this thing, we've tried very hard to stay policy neutral. And some of the comments can be interpreted as, too policy neutral is bad because somebody could do something bad with it.
This is the fundamental thing that I think is whether DRM-like policies are expressible in the system, I think is where most of this stuff comes from. And DRM policies in the broader sense of the word, the DRM policy in the sense of my corporation can keep a private key, which is I can use, but is outside, which I can't see and use arbitrarily. So, now one of the things we could do is to say that by default, such functionality is not available. When you buy the stock system, you could not get all of the stuff that's on your platform. It's under your direct control. You can read all the secrets on the system. And have people opt in to enabling DRM. And then it would be up to us to provide the services and the interesting applications for corporations to make people want to do that.
Gene patiently had his hand up with.
All right, so let me suggest an approach here. I've already mentioned that if you get some people who are involved with a little bit of the social and ethical issues, the legal issues involved, to at least talk about this, that's a step to create awareness.
Yeah.
But what you can do is, in producing this, we've seen a lot of documentation about it allows you to have this, it allows you to protect this, and those are all presumably good things. A manual, perhaps, or a documentation that says, here are all the things you can do, including if you're running a Nexus that's been programmed by somebody else, it allows them to see the following things on your machine, if it's programmed that way. If this is presumably a PC, personal computer, I'm giving someone else control because I can't reverse engineer that code or look at what's inside of it.
Well, you can, but I understand your point.
Yeah. Well, the average person can't.
Right.
And so if we say the technology gives you all these things, here are things to beware of. Here are some possible symptoms of how it's manifesting itself. Then what you've done is you've given them a little bit more information to empower their decision.
I absolutely agree that we should do that. There's no, and I'd expect the final documents would certainly do that. Maybe we should do it way before that.
Because now what we've been seeing, particularly by the people who have been very negative, is they're trying to balance the positive aspects that are being promoted rather than the discussion of the technology's general usage.
Yeah, to be fair, the one thing that's frustrating to us, and maybe we should just grow up and get used to it, is we have the biggest problem with people who say the technology does X when it was designed to do not X. I mean, to say, this thing about censoring and disable probably gets our hackles up. For Christ's sakes, we've designed it so you can't do that unless,
But simply naysaying their arguments isn't going to convince them.
Right.
Instead, giving a more complete description of here are all the
I agree. Both the research and that are a great idea.
Can I ask something that follows up on Virgil's question and your response to it? And maybe this shows that I just didn't fully understand the system. Yesterday, everybody was, among other things, one of the points was that people are concerned about global unique IDs. People don't want to be in a position where messages coming out from them are labeled with a global unique ID. Now, it sounds like what you're saying, of course, is you could have a nexus, and you could have applications running on top of that nexus that do not communicate anything that looks like a global unique ID. But it sounds like, am I correct in saying that one of the concerns is that somebody, if they have something valuable enough, either valuable intellectual property, or in the case of the Chinese government, your paycheck, could insist that you run a nexus that provides that makes it possible for things to have a verifiable global unique ID linked to you. Is that correct?
So the actions that can be, the access control and the actions that can be performed on the system is access restrictions that the hardware provides, access restrictions that the hardware provides, and access restrictions that we will provide on top of software. The hardware, if the owner of the machine, the guy who was physically present when the thing was switched on, or your OEM acting as your proxy, set the thing up so any software can run and any software can do anything, then that software could absolutely use globally unique identifiers wherever it chose to on the internet.
And can use one of the keys as a global unique identifier for a computer. Yes.
So now, so that can absolutely be done. So let me say what we will be doing. What we will be doing is shipping a platform where globally unique identifiers are only revealable to entities identified through certification that the owner has identified as being parties that they trust. VeriSign, for instance. Okay? So you can now get, using the hardware identity, you can get, and this trusted third party, you can get a bunch of identities, bunch of keys held in software that you can use for other interactions on the internet.
And so it's possible for somebody to write a nexus, or even write applications under your standard nexus that can use this key as a global unique ID.
And easy, incidentally, it's easy to do right now.
Probably
really easy to do right now.
But I take it the concern is that this would make it easier for this person to actually verify that indeed he's getting the real global unique ID and
while
not
you're connected. Yeah.
Right. So the concern is that other people can do that through the leverage. And your answer, I take it, is simply that people should resist that, and people should run nexuses that don't demand that.
So my answer really is more that we will try and put options. We will try and put a default configuration that protects the owner's privacy, and we will work with OEMs and entities like VeriSign to get legal agreements in place saying that if I were to show you my public key, then you're going to take certain, you're going to do certain good things, not tell everyone what keys you've issued, stuff like that.
The Chinese government could easily demand that you insert your smart card into the machine
that's right.
to get paid.
That's fine. That's perfectly fine in China. But
Right.
you don't have to legislate something in the design.
But see, we got to.
Oh no, but we haven't done that. We've been careful not to do that.
I'm not saying that you did. I'm
Okay.
just saying be aware of it.
So I don't think it changes that equation at all.
Well,
The smart card doesn't have access to memory in the way the Nexus does. Right?
But his example was you don't get paid unless you insert unless you present the global unique ID. And if some government wanted to do that today, they just issue you a smart card and say you're not going to get paid unless you present the smart card.
Well, I think what Gene was saying is that it goes further because the Nexus has access to all your other stuff potentially. Yeah. And,
While it's turned on, incidentally, one defense is that
Yeah.
you take all your stuff off when you're deciding to talk to the Chinese government. But okay.
But it's certainly true from the highest level. I would like there to be pull for people to want to enable these sorts of stronger authentication features. I mean, do people want to have stronger authentication tokens with their bank? Do they want to have software to be able to manage that sort of thing, those sorts of keys, those sorts of identification credentials more securely than they can today? I would like to think that we could sell and configure the system so that the people want these good things and are not concerned about these sometimes rather, the sorts of worries that, quite frankly, one person in 100,000 in the US is really worried about.
Hey, Paul, this might be a good time, particularly for the privacy people, to circle back to some things that came up kind of sporadically before. John talked earlier about zero-knowledge proofs, something called direct proofs, which are either the same or different. I don't really know.
Okay, so let me say a few words about that.
And then also ephemeral keys. I mean, could you just walk through each and every one of the design, decisions we've made that try to address this very issue?
Yeah. So this, what I was just describing a minute ago was to say that you use a root key to acquire these pseudonymous, whatever the word is, keys.
Pseudo-anonymous.
Maybe they're linked directly to your identity. Maybe they just say that your platform is one of a particular class. Any sort of key you want. We call this mechanism these second-level keys identity keys, and the acquisition of these keys, the protocol is defined in TCG, and we'll be using something rather similar. That's what is supported in TCPA, or the TPM 1.1 specification, which is out there now. We are working extremely hard on getting an alternative attestation mechanism based on zero-knowledge techniques to go in the TPM, which will be needed to support NGSCB Palladium. The sort of history of this is identity keys and identity key acquisition is pretty much okay if you believe that your identity key provider is going to honor good business practices, and if there's a business for these guys to exist. And those were both questions that we thought about hard, and this is the best we had. However, Intel came up with a zero-knowledge protocol to replace the attestation protocols, which are basically just
supplement. You can pick. I mean, we're not taking the other one out. It's just pick one.
This will be an addition. So it's a zero-knowledge protocol. It's called direct proof, and it essentially allows you to prove that your platform belongs to a certain class without revealing what platform it is within that class. So Compaq, say, or HP, say, could generate machines which could authenticate themselves as being a member of a class without saying which one. Of course, the challenge with all of these zero-knowledge protocols is how do you do revocation in a sensible way? How do you make sure that the first break doesn't mean the whole system collapses? And Intel and its refinements by IBM and HP have come up with a fairly elegant solution for this. I don't know whether I am authorized to send anyone the specs. I think the best thing I can point you at is Ernie Brickell gave a talk at the RSA conference talking about this direct proof protocol, and there will be some publicly available slides there and maybe a paper.
So to go back to your question, Ira, what we've done is at every point we've tried to make the disclosure of anything a matter of user choice. And for identity, any kind of key, we assume an intermediate key will be, a derived key will get used for an actual transaction. And we've tried to put mechanisms in place so that by policy, user policy, those could be as anonymous as possible. And direct proof is the, is the total left wing of that. Like nothing gets disclosed about your identity. So the one, I wouldn't call it policy. The one thing we tried hard to do is to make sure it's all useful without disclosing identity information, if at all humanly possible.
There's actually a knob within. There is a knob still within direct proof, and we're going to be going out to the privacy groups and privacy advocates with telling them about DP and telling them about this knob and where we think the sweet spots are for the setting of this knob. I would be happy to forward the names of people in this room who are interested to the TCG working group in order to, if you want to be involved in these discussions.
I want to raise a separate topic, and that is the software design and the software that's going to be built in the context of the Trustworthy Computing Initiative. So you're right now, Microsoft is Target stuck its neck out 2 years ago and said trustworthy computing. And so now, a Palladium comes across as a really trustworthy platform, if you will. And so it seems to me that you can't shy away from the words like guarantee and verification. Tell me what it is that you're doing to provide higher confidence for the customer that the Nexus is truly a trusted computing base.
Yes. So I'm not sure.
That any NCA that interacts with it.
That's the part I'm shying away from. We cannot prove that any NCA that talks to it is okay.
But you can tell some NCA developer, like Microsoft itself, what needs to be done.
Yeah.
Correct? I mean, for instance, Steve Libner and his team is presumably going to be the one doing the security audit and the security push for
They will.
That would be fun.
So
And they'll have a great time.
Give them,
So there are two things. We do follow development. First of all, the Nexus itself is unmanaged code. There is a development methodology.
It's unmanaged code, and you mean it's written in C?
C. It's written in C.
Okay, and there's going to be some eyeballing.
Oh, there will be lots of stuff. No, actually, there's more than that. There is actually a formal proof mechanism for parts of it. There is actually a well-developed methodology for it. For NCA developers, ultimately, we do want them to write managed code, and again, the environment itself should help protect them. So I'm not shying away from that. And in addition, for the Nexus, we're actually making the code available.
But does that mean that the Nexus will include the CLR?
It means that the CLR that we publish had better be part of the is it a part of the mandatory TCB? Yeah, if you write managed code, it's part of the mandatory TCB. So there's an argument in favor of making that available too.
I don't think we've said we're going to do CLR for V1. It's part of
right.
Yeah,
that's part of the.
But it certainly will not be part of the Nexus.
No, it will not be part of the Nexus. No, but I think his point is if the only way to write secure applications is to use a CLR, then maybe that's part of the TCB a lot of people are going to rely on.
You obviously have built an experimental system that you referred to. Parts of it is proven to have a particular set of properties that you consider desirable. I'm referring to the Nexus. Could you give us a couple of examples about the kinds of properties you prove?
Copy for PTO
So properties we proved about that particular piece was sort of fairly. There were sort of relatively low level properties of that particular algorithm. So, for example. And I'm making part of this up because I have to get back and look at this exactly proof there. But so it was supposed to be this isolation algorithm. So we started out with the core part of the proof is you sort of prove a bunch of invariants about the system behavior as sort of actions by the guests come in. Which in sort of the most low-level technical sense simply means you don't get to establish, if you're a guest, you don't get to establish a mapping, or you don't get to access the page that the SK had assigned to a different guest.
Did you use any of the proof techniques and model that John Rushby had in his thesis? No. Very good start, by the way. Separation kernels.
But you did say you used some theorem proving technology.
Yeah, we essentially formulated. So we made a formal specification of the algorithm in first order logic. Ran that specification through a resolution theorem prover, and in this initial stage, we essentially mechanically translated the this first order specification into, not mechanically, I mean by hand, translate this first order specification into C code. Our hope will be to get to a stage where at least for core parts of the system, such as the machine monitor parts, to actually be able to have a mechanical translator from our first order logic specification into C code.
Do you interact with Leslie Lamport on this one? Do you interact with Leslie Lamport?
We do. And essentially, yes. So we went. So he's currently not actively involved in doing the verifications here, but we've certainly this very same talk that I've given here. We went down to Mountain View and talked to him about this.
Can I change the subject yet again?
Yep.
My concern, so I'm a software developer and a software tester. And my concern is that this thing's going to be a bitch to test. I look at this, and I see to test. I see the requirements of new tools. I'm going to need to monitor every single interface going across from agent to app, going from agent to Nexus, and I'm going to need to verify that all of these things that are secret really aren't being passed over these interfaces. So I see this as a really grand challenge for, I guess, these guys.
And don't forget the secure channel from the...
Exactly, right. All this stuff...
Actually, Jeanette has guaranteed that we'd have a tool that would do that job perfectly.
Have I?
Yeah.
So you got Jeanette, you got Steve. Now, so I think you can handle that. There's no question about it. I've been working with Microsoft testers long enough to know you've got some smart people here. My concern really comes in with third-party developers who now see, hey, this is great. Look at this new platform. They come up and they write an application, and it's going to be harder than normal applications because they got these NCAs to write, and they have to worry about these things. And they have to make sure that, all the decryption really does take place over there, and no key material passes back and forth, and blah, 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 blah. They end up screwing it up royally, and a bug gets posted, a bug goes to cert, advisory is issued, and guess who looks bad? Microsoft.
So the first thing is that will happen.
It will happen.
It will happen.
So what are you going to do? Do you have? Have you started thinking about how you're going to educate third-party developers? How you're going to, are you going to start issuing test tools for them?
So we actually, as part of this effort, we're making we're enhancing Visual Studio to have more tools that are Palladium dependent. Now, I wouldn't say that we have this as a fully baked solution, but we're thinking about all the things you've said.
Okay, well, let me add one more thing to think about.
Which is not to say it's a solved problem.
Right, right. Maybe you already are. Yeah, and I don't have any solutions yet either, except, just roll your sleeves up and start writing some good code.
Yeah.
But one other possibility is you've got this Certified for Windows program. Have you thought of Certified for Palladium program that you could do?
We could do that. And I actually would like advice. I'm a little bit torn about certification programs because every time Microsoft certifies something, it's just makes me nervous. That's all.
Microsoft doesn't certify for Windows. Veritest does.
Okay, but somebody sets up criteria.
Yeah.
And often Microsoft is in the middle. So I do believe there needs to be a certification program.
Well,
I'm clear in my mind how much we should have to do with it. Just
the way it happened with Certified for Windows was that Microsoft used its own money to pay a colloquium of industry experts to design the test bed and the tools, and then Veritest charges for the service of executing those tests, and it's actually Veritest that recommends to Microsoft to issue the stamp for their shrink wrap.
Whose private key signs it? A Microsoft key or Veritest?
Microsoft.
That's just okay. So I think everything up to that sounded great to me.
Okay, well that's just the way it works out. I mean, it doesn't. I'm not making a recommendation.
No, I know.
But I have to put this in the context of the previous discussion. So you're suggesting to us that we can plan in a policy.
I'm suggesting that you got a serious problem on your hands and you got to do something.
No, wait. Let me see if I understand. What you're saying is, when a third party wants, we would make a service available that somebody would sign a certificate, not insert policy to say, this complies with the policy of whatever this group is, right? That's what you're suggesting.
I'm suggesting when you start writing NCAs and applications for Palladium, you pay attention to what works and what doesn't work, and you publish it and you make it available somehow.
Right.
Maybe some third party, you license it to some third party vendor who then goes out and certifies these things themselves, or you make it available in some SDK or in Visual Studio.
I agree.
Because you could look really bad over this if you make it so that these applications are possible to run.
Right. Oh, yeah.
But documenting best practices and providing tools to help ISVs build effective or secure NCAs is a no-brainer.
Not necessarily, Steve. Think about this, because these tools that you're going to have to write, I know because I've written one. These tools are in and of themselves the best way to hack NCAs and poorly written NCAs. The best way to test them is also the best way to hack them.
Okay,
so if you start releasing those out into the world,
I mean, there's a set of trade-offs, and you get specific. What I'm saying though is that we obviously have to tell people how to write NCAs as securely as we can, as they can. I think what John's saying, and I agree with him, is that going the next step and certifying them, or maybe going the step beyond that, and providing some technical implementation, which I think the framework probably could do, so that if it ain't certified, it don't run, or if it ain't certified, it's
at a disadvantage.
Yeah, that's that makes me twitchy. I assume that was what was making you twitchy.
I was twitchy about that. Yeah. But again,
I didn't mean to
if we design the system right, the availability of those tools does not decrease the security of the underlying system, because it's hardware-based, that thing. So in fact, what I'd say is I want all those tools. I completely want, unlike the DRM stuff where part of the protection is in the secrecy of how you've done it. I want a system where 100% of the tools that make it safer to build can be available to people, and it just doesn't hurt whether it's secure or not.
Okay. And I think it's also, at least again, my expectation that the early adopters of this thing are going to be people who already have software security products and they know what the deficiencies of those products are. So there are people on our team who kind of think this is the platform for every development platform for every I think it is much more, the people who write secure email clients, the people who do secure log-on packages that are going to be interested early adopters of this. And I think they're going to learn from us and we're going to learn from them. I mean, it isn't going to be the case that we just ship this thing and everyone's going to be on their own. There are going to be some people that will, preferred ISVs that we're going to work with to see what works.
So kudos for thinking ahead.
Oh, well, you can never do too much of that.
I do a little bit of that.
So for the second round of applications, so the first round, sort of the most interesting from a perhaps consumer point of view would be secure email. Not that I think that, that's a separate issue, but what about the second round of applications? So you're going to warm the community up with this Palladium.
So I think an interesting first.
And so then how are you going to lure them to the second generation so that they'll be more pervasive and everyone will have this on their desktop? I mean, on their desk.
I think secure transaction authorization is a more compelling scenario.
So that would be the bank
security
or e-commerce?
Yes. But we change. I am much more concerned with getting a good platform.
Yeah,
Other people may have stronger opinions as to what.
Well, no, I actually have a pretty strong opinion.
The question is this.
Yeah.
Who's going to want to buy it? You're clearly going through a lot of effort.
Yep.
With the hope that there's going to be this mass market out there, and you're going to make some money on this.
Yeah. So for the first version, it's corporations. If you're asking the market question. So again, we have to tread a fine line. But the problems we often get ourselves in. We had this discussion just the other day with let's make everything transparent, work perfectly, blah 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 blah, and then what happens is one of two things. It never gets out. That's not so good. Or it gets out and it has problems that people have always had with software development. Put too much stuff in, and they didn't have a clear answer to what it stops and what it doesn't. And that I'm actually fairly hysterical about doing neither of those two things. So I'd actually rather have a minimalist system than I mean, I do want to lure people in, to tell you the truth, but I actually, luring loses to actually, being clear about what it is right now. Maybe in version 2 that'll change a little bit. Yeah.
I guess this overlaps very much with what you were just saying. And there seems to be, secure e-commerce to me sounds like a terrific way to use this, but until everybody's got the platform, it's not going to happen. And until it's happening, then nobody's going to spend the extra few bucks to buy the platform. How do you get over this?
Well, so you're right. It's a classic problem. It's always the chicken and egg problem, and obviously we solve it because we have computers which are a lot more powerful. And Word, with whatever the stuff they do right now that's made it a big, attractive platform, didn't do that in the first version. So they grow. The platform and the applications grow together. I think that we have a couple answers to that. I don't think there's going to be one killer application. I just don't think that. I think different crowds will have different things. The killer feature is the security feature, and I think for corporations, let's take version 1, you'd have to be crazy not to spend the extra $5. I mean, ultimately, it's if you can't, maybe I'm just being too ethereal here. If you can't see the benefit of the extra $5 over potential applications, somebody should fire you. I'd be willing to fire you for years.
Why isn't the killer application just boot loading verification?
You mean secure boot?
Yeah.
That's probably a good application, actually, one we're talking about. But what did that buy you? You still have this big lump of code, which may not be terribly secure.
But I'm a corporate entity. I want to make sure people have installed stuff.
You know what? And that's one. We didn't mention it. That's one of the things we'd probably support in V1. We call it authenticated, not secure boot.
Okay,
you're still in control of the machine. Boot whatever you want, but just authenticated. You booted the right thing.
I think, though, whether you sell this or not, so for example, yesterday we were saying, you're building all these nice test tools and you've got all these threat models, blah, 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 blah. Who's thinking about architecture? So now you come in here.
Who's thinking about what?
About architecture. Why not build a better operating? So now you've come in here and you showed us that you've thought about architecture. You're building a better operating system. And to me, whether you ever make any money on this or not is a worthy piece of work just to find out if it works or not. And you're a company that can afford to just figure out whether or not it works. So maybe it won't work, and then
I don't think I'm going to use that argument.
We go back.
I think it's a fine argument, and I buy every bit of it, but I don't think that's the one I'm going to use in the next Build TV.
It's fine for an academic board, but
yeah.
I'm going to take that up in a little bit more general sense. There are a bunch of things we're doing with the platform here. We're essentially taking one vertical slice of the things we could possibly do. You've heard about here a high assurance kernel running on top of a high assurance machine monitor running on top of hardware. All the work we've been doing over the last 5 years is to keep our options open for other things we could do with it. So being able to run a mandatory access control system, running high assurance mandatory access control, machine monitors supporting mandatory access control, running Connectix, running XP. Yeah, love to do it. We're talking to the Connectix guys. I really hope it happens. Secure boot. I have personally sat down and prototyped a version of Secure Boot using the mechanisms that we've been putting into TCPA. Love it to happen. There is a huge...
You mean Secure Boot in the Bill Arbaugh sense, or...
No, it doesn't.
No?
What do you mean by secure boot?
It's sort of, you could say an Arbaugh sense.
We're getting the signal that you should talk close to the microphone.
Secure boot in the sense of it, we could argue about where we start off, whether we start off in the BIOS boot block or whether we start off in the operating system. But say we start off in NT loader, and say NT loader will only load a known good version of NTOS kernel, HAL.dll, and then only load authorized drivers, and then maybe, according to user policy, only load authorized applications. So definitely an application. Love to see it happen. At the most mundane level, we've got this little crypto chip down here, and without any of the authenticated operation, without the projection of trust from the hardware into software, this thing is a pretty good key store. I'd love to see, regardless of whether this project here is successful, the TCPA key store find functionality. So, yeah, great. Another thing you could say is we've kind of got as far as we have got by being relatively disconnected. So we're writing this thing off to the side with rather few dependencies on the main OS and rather few changes to the hardware. With these changes, now that the hardware is becoming real, whether other parts of the company will start to exploit this hardware to do more profound things with security in the main OS, be super if it happened. But we couldn't take that dependency early on because of the chicken and egg problem.
So let's pass one. Let's take one last question.
It's a suggestion.
One last suggestion.
There was talk about where would be good application for this. Well, I just happened to get an email. An area of great interest right now to many of us is the whole area of electronic voting and online voting machines and voter verifiable audit trails.
Somebody mentioned that in the restroom.
Yes. So this would be a technology that if there was an open source platform that would be running on a trusted nexus that we could tell was running, the voter could verify that it was in fact the fair software. This could actually be used in many places around the world. It would be a great demonstration that this is not simply for DRM and would be some of the realization. So you might want to see if there are some people, organizations, that you can see this.
I live in Florida. We'll buy it. We're the ones that determine who's in charge anyhow.
Yeah. David Dill is someone who's been working on this. Maybe he'd be interested. But
where is he?
Stanford. And the USACM just co-sponsored a workshop in Denver on this that had standing room only crowd. So as a thought, coming up with some examples like this and actually helping to seed them, to show how the software is to be written, how it can be used to benefit the public, might actually be something useful to do.
Great. I want to thank everybody. Fred, thank you for suggesting this.
Thank you, John.
I really appreciate the comments.